Alright, so for today's lesson, we're going to just practice calculating kinetic and potential energy some more. So you should all have a worksheet in front of you that's titled Kinetic and Potential Energy Worksheet. All we're going to do is we're going to work through the first few questions together, step by step in the video. You'll have an opportunity to stop and answer the questions, and the video itself will pause. You can do all of your calculations right on your paper, or if you prefer to use a scrap piece of paper to have more space, you can certainly do that. And then whatever answer you get, you're going to enter in on the question on the actual video itself. Now realize it will mark all of your answers incorrect for now. I have to go back through to approve them. So please don't panic when you see that all of your questions were marked wrong. As long as you hand in your work to me at the end of class, or if you don't finish during class tomorrow, then you'll receive at least partial credit. If you get the answers correct, you'll receive full credit. So let's look at number one. Now, number one says you serve a volleyball with a mass of 2.1 kilograms. So again, I am not going to force you to write down things as you go, but for me it's helpful. The ball leaves your hand with a speed of 30 meters per second. Now on the top of the paper, they break down all of the units. You don't need to do that. So they'll mention the energy is in joules, weight is in newtons. A lot of you yesterday had lots of questions about the specifics of the units. I would love to sit down and have that conversation with you, but today's video, we're just going to do an overview. So we have mass, we have speed. It says the ball has blank energy. Now you're going to decide, does that have potential energy or kinetic energy? So go ahead and write your answer on the line on the worksheet, and at this point in time the video should stop and it will ask you to put your answer in on the right hand side question. Alright, once you've decided whether it has potential or kinetic energy, we have to decide how to calculate it. Now I'm assuming you've already entered your answer, so I'm going to tell you it has kinetic energy. Now yesterday we talked a little bit about a frame of reference. Okay, if you were serving a volleyball, I would imagine it wouldn't be flat on the ground. So technically, yes, this ball does still have some potential energy, but we want to focus on the data they provide us in the question. So they're talking about the ball traveling with a specific speed. That means for this question, we're focused on the kinetic energy of the ball. This chapter really is just an overview of basic types of energy. So we're going to calculate the kinetic energy of the ball. So if we look at the top of our worksheet, they remind us of our formula. Kinetic energy equals half times the mass times the speed squared. So to solve it, I'll use red. We're trying to find the kinetic energy. So the half doesn't change. Now let's plug in our mass. Well, they said our mass was 2.1 kilograms. And then our speed was 30 meters per second. So if we plug that in, don't forget to square the speed. Now, as you go through this, you can certainly use the calculator on your laptop. When we do eventually have the test or quiz for this chapter, you'll need to have a standalone calculator. So if you have your own, feel free to use it to get more comfortable with it. If not, the day of the test, I'm sure that we can borrow some of Miss Bretton's. So, if we have 30 squared, if you plug that into the calculator, that would give us 900. And I'm going to write this down step by step as we calculate things. If you can do it all in one step in your calculator, that's fine too. So the next thing we need to do is multiply 2.1 by a half, which is the same thing as dividing it by 2. That would give us 1.05. Now, normally I tell you to round to the tenths place, but if we're step by step calculating, you probably don't want to round yet because that could affect your answer. So now we need to multiply. So 900 times 1.05 would give us 945. So that is our kinetic energy. Whenever we're solving for energy, we're going to use the unit of joules, which is just a capital J. Again, if you want to know exactly what a joule means, I would love to sit down with you and break it down piece by piece. But all you need to know is the unit for energy is in joules. So we've completed the first problem. And just a side note, energy does not have a direction like displacement or velocity would. So you will only need to write joules. even if they have a height or a direction in the problem, you won't put it with the energy. So at this point in time, we solved this one together. So if I went a little fast for you, go ahead and copy down our work somewhere, scrap sheet of paper on your paper, and then the video is going to pause and give you time to submit an answer. This one you had all better get right because we did it together and the answer is literally circled on your screen. So go ahead, take a minute to submit your answer. Don't forget your units. Alright, now we'll move on to question number 2. So this question, a baby carriage is sitting at the top of a hill that is 21 meters high. So that seems like a height to me. And again, just like with speed, we are using a frame of reference. So technically, we're on the Earth, and the Earth is hovering in space, so really, if something's on the ground, it's not actually at a height of 0. But we use the ground as a frame of reference. So everything that we do height-wise is measured from the ground up. So this 21 meters, we're going to assume is just a height of 21. Alright, the next sentence. The carriage with the baby weighs 12 newtons. Ooh, we haven't talked about weight really much yet. So I'm just going to write that down, and then we'll try and figure out what that means. The carriage has blank energy. Okay. Well, first of all, if the carriage is sitting at the top of a hill, it's sitting. It's not in the grand scheme of things moving. So take a minute and type in your answer for the type of energy it has, either potential energy or kinetic energy. Alright, so hopefully you entered that the carriage has potential energy, because again, this question is focused on the height of the carriage in reference to the ground. So we're going to need our equation for potential energy. Now, yesterday we said potential energy is the mass times gravity times the height. Well, we don't know the mass of the carriage, we know the weight of the carriage. Well, if you look at the top of the worksheet, where it has our equation for potential energy, it says potential energy is mass times gravitational acceleration times height. And they round gravity to 10. We're not going to be lame like that. We're going to keep it 9.8. Now, they have in capital letters and bolded the word or. Weight times height. So last chapter, I think for maybe a half of a minute, I put on the board, hey math group, write down weight equals mass times gravity. And then we never really used it again. Well, now we are going to use that. This is going to help simplify things so that we don't have to do quite so many calculations. Last chapter, we defined weight as the force acting on an object's mass based on gravity. Well, now this is the math representation of that. So whatever your weight is, all that means is based on how much stuff you have, based on your mass, gravity is going to pull a certain amount on that. And that's what we would think of as weight. That's why if you go to the moon, you feel like you have less weight. The amount of matter that you have didn't change. Your mass didn't change, but gravity changed. So that's the formula that we are able to use for weight. It equals mass times gravity. So all we did in this problem is instead of using mass times gravity in our potential energy equation, we substituted. So we can now say potential energy equals the weight times the height. So either equation is acceptable. If in the problem they give you the mass of the object, use our first equation. If in the problem they give us the weight, then we'll use this one. It just saves you from a step of work. So we go back to our problem. So PE, well, they gave us the weight of the baby carriage. So let's use weight times height. And I'll solve this one in green. So they said that the weight was 12 newtons. Now we think of weight in terms of pounds. Newtons is just a more generic form of that. We are able to convert between newtons to pounds, but we're not going to do that today. So we have a weight of 12 newtons and our height was 21 meters. Alright, so if we go ahead and multiply that out, we have 12 times 21. And that gives us 252. And what are my units going to be? Right, joules. Hopefully that's what you said. I'm just pretending. So that's our answer. The potential energy of the baby carriage and baby was 252 joules. All right, so again, the video is going to pause. Take a minute to copy down our work if you didn't do so already, and then take this exact answer, and once the question pops up, you're going to put that answer into the question answer box. Make sure you have your units. This is the last one we're going to answer together. The next one, I'm just going to help you get it set up, and then you're going to solve it. All right, we're going to set up one more question together, and then you'll have the rest of class to work on the remainder of your questions. If at this point you feel confident and you want to try working on your own, then what I'd say is go ahead and work ahead. Unfortunately, you can't skip forward in the video, but you can let it play through and you can check your answer and then store your answer once you've completed the work. So we're going to do question number 3 together. So it says a car is traveling with a velocity of 40 meters per second. Now, one thing I'm just kind of noticing now that we should probably address. This question uses the term velocity, but there's no direction associated with that. So that is a downfall to this question. And unfortunately, it's a common occurrence when we talk about energy. Because energy itself doesn't need a direction, lots of times when people are writing questions, myself included, we forget to put the direction in. Technically, this question is not phrased correctly. It should say, a car is traveling with a speed of 40 meters per second. Or, if we wanted to use velocity, we would need to add a direction. So, again, you don't need to edit the question at all. Just realize I'm apologizing. I should have gone through and fixed that earlier. So, the car is traveling with a speed of 40 meters per second and has a mass of 1,120 kilograms. The car has blank energy. So take a minute and decide what type of energy we're focusing on in this problem. All right, hopefully you have stored your answer by now. The correct answer was kinetic. Again, we're talking about motion or movement. We have speed involved, so we're going to be looking for kinetic energy. So our equation, KE equals 1/2 mv squared. Now, at this point, the video is going to pause, and I want you to try and solve this question. Keep in mind our equation. So take it step by step. Don't forget the squared. Don't forget the half. Once you have solved your answer, please type it into the answer box. Don't forget your units. After you answer the question, I will show you how to solve it on this video, and then you'll have the chance to move forward. All right, so hopefully you've stored your answer. I'm going to solve this really quickly. We had KE equals 1/2 mv squared. Our mass, we can't forget our half. Our mass was 1,120, and our speed was 40. So if I have 40 squared, that would give me 1,600. And we need half of 1,120. That gives me 560. When I multiply them together, our final step, that gives us, oh goodness, 896,000 joules is my unit. This is the correct answer. So hopefully this has started to make sense. If you're feeling bored with this and you want some more challenging problems, you will have the chance this chapter to take it a step further, where instead of solving for the speed, you may be solving for, instead of solving for the energy, you might be solving for the speed instead. Same equation, it's going to involve a lot more algebra. So hopefully you're feeling a little bit more confident. At this point in time, you can go ahead and close up the video, although do wait until it actually stops on its own so you get credit, and take the rest of class to work on these questions. If you would like to work with someone, as long as we haven't lost that privilege so far today in class, you are good to start working together on these problems. Thanks, guys.